Hi guys, in this video I'm going to show you how to compute a weighted average and also show you the fundamentals behind it. Okay, so for our example here we have 6 students taking 3 exams over the course of a semester, and these are their grades for the exams. So for example, student 1, test 1 65, test 2 65, test 3 62. Student 5 had an 83 on the first, 64 on the second, and 81 on the third. Now, I want to compute the regular average, and we know in Excel we can use the equals average function. Highlight the 3 exams for a particular student, close the parentheses, and we'll get the average. In this case, 64. That is the regular average. But do we know that a regular average is a special case of a weighted average? And the special case being that all of its weights are equal. Now, what do I mean by weights? Well, if there's 3 exams and we're taking an average, then there's 3 weights. 1 weight per exam. Okay? So, the 3 weights in a regular average would have to be of equal size. So what you would do is you would take 3, the number of exams, and divide 1 and divide by 3. Now why do I divide 1 by 3? Well, all the weights must equal 1. So there's two things going on here. First, we have to understand that the total sum of our weights in a weighted average must always equal to 1. Okay? And if we're doing a regular average, like we've done countless times throughout grade school and in college, then each of the weights is of equal size or equal weight. So all of the weights have to add up to 1, and we have 3 weights, then we just simply can divide 1 by 3, and we would get 3 equal weights of 0.33333333. Okay? And that's what I have written over here. Okay? The first row. Okay? These are the weights for a regular average when doing a regular average of 3 numbers. Okay? So let's compute a regular average, this time doing it a different way, and that is using weights. So let's do equals. We take the first exam and we multiply it by its weight. And I'm going to lock that cell. Okay? That means put dollar signs. If you're not familiar with absolute referencing, there's videos on that. But here we're going to focus on just taking weighted average. Plus the second exam times its weight. Plus the third exam times its weight. Okay, so you see what I did? I took each exam and multiplied it by its weight, and then added that to the next exam by its weight, next exam by its weight. Okay, and you see I get very close to 64. The reason why I don't get exactly the same answer as the previous way we calculated the average is because I should add many more 3's here. And if I add many more 3's, this will get closer and closer to exactly 64. You see? Okay? So that's how you compute, and then we can just drag this formula down. That's how you compute weighted average when you have a regular average using weights. Okay? So let's do a weighted average where the weights are not equal to each other. Okay? So for the weighted average, in this example, weighted average 1, this may be, this is saying that the first exam is worth 25% of your final grade, the second exam is worth 25%, but the third exam is worth 50%. Notice that the 3 weights add up to 1. If I add these 3 numbers up, it equals 1. And we need that to be true. Okay? That's true for the first one as well. Okay? So we do it in the same exact way. The first exam times its weight plus the second exam times its weight plus the third exam times its weight. Okay? And so you see with this weighted average, our average for the student is actually lower than the regular average. Okay? In this weighted average, we put much more emphasis on the third exam, and put less emphasis on the first two exams. But this exam plus this exam plus this exam must equal 1, just like over here. Okay? 1. Now, to do it one more time so that we can drive this point home, I've done another weight scheme, and this is weights for the average, for weighted average 2. Now here we have much smaller weights for the first two exams and a much bigger weight for the third. So here it's saying that the first exam is worth 10% of your grade, the second exam is worth 10%, the third exam is worth 80%. So the last exam has a lot more weight. Okay? That's the point of weighted averages. You're giving more emphasis to certain values that you want to average, whereas in a regular average, you're giving equal emphasis to every number you want to average. Hence, you have equal weights for each number. Okay? I hope this is being driven home, because the point of these examples is to repeat until it finally sinks in. So equals the first exam times its weight plus the second exam times its weight plus the third exam times its weight. And then we can just hit enter. And since that third exam has a lot more weight for this first student, this third exam has a lot more weight, right? 80% of the final grade, and it's the lowest of the three. That's why it's pulling down the grade, right? Okay. So, and if we go back into our formulas and we actually lock the weights, absolute reference them, we can pull these formulas down. And absolute references are really important when you want to do things like this and you don't want to retype formulas over and over. What I'm basically doing, and if this is new to you, you should definitely watch another one of my videos where I go through this specifically. But wait, what I'm doing here is that since I'm multiplying this guy by this guy, right, and this guy by this guy, and this guy by this guy, and adding them, right, all along to each other, when I pull this formula down here, all these references will also want to move down. Okay? And I want these references to move down as I pull my formula down, right? Because I want it to move to student 2 when I pull the formula down to student 2, and then to student 3, and then to student 4, and then to student 5. So I want these references to move down. But I do not want the weights to move down, because this is weighted average 1, and I want the weights to stay on weighted average 1. I want these to stay stationary as I pull my formula down. So I lock these. I put the dollar signs around the references from the weights, right? These guys have dollar signs around C5, D5, and E5, and no dollar signs around C9, D9, and E9, so that C9, D9, and E9, this one, will change when I pull the formula down, and C5, D5, and E5 will not change when I pull the formula down. Okay? And that's weighted. That's absolute. That's a little brief, compact explanation of absolute references to you. But what I want you to take away from this video is that a weighted average is very similar to a regular average, except that we put more weight or less weight on certain numbers that we are looking to average. And the way I wanted to relate this back to a regular average, which we're all used to doing, is that a regular average is like a weighted average, except that the weights are equal to each other, right? 0.333, 0.333, 0.333, they're equal. And always the weights have to each sum up to 1. So if there were 4 numbers we were averaging, the weights would be 0.25, 0.25, 0.25, and 0.25. And if there were 5 numbers, each one of the weights would be 0.2. If there was 10 numbers, the weights would be 0.1, and on and on and on and on. 0.1 for each of the 10. If there was 20 numbers, the weights would be 0.05, right? Equal weights for the 20 numbers I want to average. That would be a regular average, okay? These would be examples. Weighted average, we're putting different weight on different numbers, and that is up to the person taking that weighted average, depending on how much emphasis he wants to put on different numbers that he's averaging, okay? And so that's it. I hope you got weighted average and also know how to compute it in Excel, and you got a little bit of a summary of absolute references out of this as well. Make sure to subscribe to my channel and check out my other Excel, Access, PowerPoint, and mathematics tutorials. And until next time, practice, practice, practice. Have a great day.